Good afternoon, everyone. Am I audible? Good afternoon, everyone. Okay. So, yesterday we were discussing about force on a charge that is moving in a region of magnetic field. So, we will continue that topic today also. So, ये हमने discuss कर लिया था यहाँ that what is the force acting on that particle if a particle is moving in a uniform magnetic field region at right angles. That means angle between velocity and magnetic field is 90 degree. So in that case, according to right hand rule for vector products and for right hand rule to find the direction of force, you can find at any point direction of force is perpendicular to both velocity and magnetic field. And if you are finding the direction of force at any point, you will find the direction of force will be passing through center. So it means that charge is following the circular path, and that magnetic force is acting like, or it is providing the centripetal force to that particle to rotate in a circular path. So what is centripetal force for any particle that is moving in a circular motion? So centripetal force is mv square by r. And what is magnetic force here? So magnetic force here is qvb, and theta is 90 degree. So theta is 90 degree because velocity is perpendicular to magnetic field. Magnetic field is inwards and velocity is in the plane. So sine 90 degree 1. So this is magnetic force. So magnetic force is providing the centripetal force. So we are equating them. So mv square by r equal to qvb. And from that, you will get, after cancelling out v and v from here, you will get mv by r equal to qb. From there, you can find the expression for radius of this circular path. And that radius is equal to mv by qb. And there are some more expressions, more forms. So what is m? We know linear momentum. Linear momentum is known as mass into velocity. That is its mathematical form. So mv you can write as linear momentum also. Linear momentum by qb. Also, there is a relation between linear momentum and kinetic energy. So what is that relation between linear momentum and kinetic energy? So linear momentum is mv. So mv, if you square it or you divide it by m, okay, what you will get? You will get mv square. That you will get if you apply, if you multiply 1 by 2 on both sides. On right hand side, you will get kinetic energy. And left hand side, what is mv? That is p. So p square by 2m. So relation between kinetic energy and linear momentum is p square by 2m is equal to kinetic energy. That is the expression. That is the relation. So we can write relation between kinetic energy and linear momentum as that also. So that linear momentum is 2m kinetic energy root. Okay, so we can write here 2m kinetic energy by qb. M is mass of the particle, that charge particle. Q is the charge on the particle. B is magnetic field and kinetic energy. So these are some form of expressions for radius of circular path of that charge particle that is in a circular motion in the uniform magnetic field. Clear? Now let's see what is R. So from here R is mv/qb that we have seen, and we know that relation between the linear velocity and angular velocity, that relation is v equal to r omega. So that I am revising you from that circular motion topic. So you should revise circular motion topic first. Okay, from laws of motion. So R is equal to mv/qb. So you can write m. So from here you can convert R is equal to v by omega. So R we can write v by omega equal to mv/qb. So from here v and v would be cancelled out, and what is omega? That is qb by m. So that is expression for angular velocity of that charge particle that is in circular motion. So angular velocity of that charge particle. And we know that what is omega? What is the relation between angular velocity and frequency? Omega is 2 pi into nu. Nu is frequency, okay, of that charge particle. So frequency का क्या मतलब होता है कि हमारे पास एक सेकंड में, और या हम कह सकते हैं पर यूनिट टाइम में, कितने रोटेशंस, कितने रेवोल्यूशंस उस चार्ज पार्टिकल ने कंप्लीट कर लिए, दैट इज फ्रीक्वेंसी. इफ सपोज एक सेकंड में उसने 5 रेवोल्यूशंस कंप्लीट कर लिए हैं, ठीक है, 5 बार उसने सर्कुलर पाथ जो है कवर कर लिया 5 बार एक सेकंड में, दैट मीन्स इट्स फ्रीक्वेंसी इज 5 रेवोल्यूशंस पर सेकंड. दैट इज द फ्रीक्वेंसी. And the relation between angular frequency and frequency, so it is known as angular velocity as well as angular frequency also. So relation between angular velocity or angular frequency with the frequency, that is 2 pi nu. So omega is qb by m. So from here you can write qb by m equal to 2 pi nu. So from that, what is nu? That is qb by 2 pi m. That is the expression. So you have to find only one expression, that is for radius. Other expressions you can find by modifications. Okay, हल्का हल्का मॉडिफिकेशन करोगे आप, r को v by ओमेगा लिखोगे, ठीक है, फिर उसके ओमेगा फाइंड कर लोगे, ओमेगा और फ्रीक्वेंसी के बीच का जो रिलेशन है वहाँ से फ्रीक्वेंसी के लिए एक्सप्रेशन आ जाएगा. और अगर हम टाइम पीरियड के लिए एक्सप्रेशन फाइंड करना चाहते हैं, सो टाइम पीरियड इज रेसिप्रोकल ऑफ फ्रीक्वेंसी. टाइम पीरियड क्या होता है कि एक रेवोल्यूशन के लिए कितना टाइम लगा, फॉर 1 रेवोल्यूशन. ओके, इफ अगर एक सेकेंड में 5 रेवोल्यूशंस हो रही हैं, दैट इज द फ्रीक्वेंसी ऑफ दैट पार्टिकल. सो व्हाट इज टाइम पीरियड? कितने टाइम में एक रेवोल्यूशन हो रही है? एक सेकंड में 5 हो रही हैं, सो 0.2 सेकंड में एक रेवोल्यूशन हो रही है. सो दैट इज द टाइम पीरियड. सो टाइम पीरियड इज रेसिप्रोकल ऑफ फ्रीक्वेंसी. सो दैट मीन्स 2 pi m by qb. That is the expression for time period. Okay, also you can see what was omega. Omega was qb by m. And what was frequency? That was qb by 2 pi m. And what was time period? That was 2 pi m by qb. So आप देख सकते हो कि फ्रीक्वेंसी, एंगुलर वेलोसिटी एंड टाइम पीरियड, इनके एक्सप्रेशन में ना तो रेडियस है ना ही वेलोसिटी है. दैट मीन्स these quantities, time period of that charge particle, frequency of that charge particle and angular velocity of that charge particle is independent of the velocity of the particle. So velocity से ये independent है, टाइम पीरियड हमारे पास क्या आ जाएगा, टाइम पीरियड इज ऑल्सो, इट इज हैविंग एक्सप्रेशन 1 बाय न्यू एंड इट इज हैविंग एक्सप्रेशन 2 पाई बाय ओमेगा. So you can put the value of omega or nu to find the time period, and that time period is 2 pi m by qb, that I have already told you. So time period and frequency is having no dependence on the velocity of the charge particle, क्योंकि उनके expression में कहीं भी velocity नहीं है, ना ही radius है, तो उनकी कोई dependence नहीं है velocity पे. Clear? तो अगर आपको क्वेश्चन आता है कि चार्ज पार्टिकल की वेलोसिटी डबल हो गई है पर उसका चार्ज, मैग्नेटिक फील्ड और मास वो चेंज नहीं किया है हमने, वेलोसिटी डबल हो गई है, तो उसके टाइम पीरियड पे क्या फ़र्क आएगा, क्या इफेक्ट आएगा? सो यू शुड सेलेक्ट द ऑप्शन विच इज सेइंग नो इफेक्ट, बिकॉज टाइम पीरियड इज हैविंग नो डिपेंडेंस ऑन द वेलोसिटी. Now, we have discussed the case where velocity is perpendicular to magnetic field. तो हमने केस वो डिस्कस किया है जिसमें मैग्नेटिक फील्ड के परपेंडिकुलर है वेलोसिटी. बट इफ इट इज नॉट परपेंडिकुलर टू मैग्नेटिक फील्ड, it is at some angle to the magnetic field, so then there will be some component of velocity that is along the magnetic field. तो हमने डिस्कस किया है पहले भी कि जो हमारे पास मैग्नेटिक फोर्स है, that magnetic force is QVB sin theta. ओके तो अगर हमारे पास कोई चार्ज पार्टिकल मैग्नेटिक फील्ड के पैरेलल या एंटी पैरेलल है, तो उस केस में मैग्नेटिक फोर्स क्या है, जीरो है. इफ थीटा इज 0 डिग्री और 180 डिग्री, इन दैट केस मैग्नेटिक फोर्स इज 0. ओके सो सिर्फ उसी केस में हमारे पास मैग्नेटिक फोर्स लगेगा जब पैरेलल या एंटी पैरेलल नहीं है चार्ज पार्टिकल और किसी वेलोसिटी से मूव कर रहा है. तो हमने जो अभी केस पढ़ा वो क्या था कि मैग्नेटिक फील्ड क्या थी, परपेंडिकुलर टू द प्लेन एंड इनवर्ट्स. ओके एंड व्हाट इज वेलोसिटी, दैट इज इन द प्लेन. सो एंगल बिटवीन वेलोसिटी एंड मैग्नेटिक फील्ड वाज 90 डिग्री. सो एंगल 90 डिग्री था, इस वजह से क्या था हमारे पास, जो हमारे पास मोशन था उस चार्ज पार्टिकल का, दैट वाज सर्कुलर, बिकॉज वेलोसिटी वाज परपेंडिकुलर टू फोर्स एंड इट वाज परपेंडिकुलर टू मैग्नेटिक फील्ड एज वेल. पर अगर हमारे पास सेकंड केस है, अगर वेलोसिटी जो है वो किसी एंगल पे है, सपोज दिस इज द डायरेक्शन ऑफ मैग्नेटिक फील्ड and this is the direction of velocity of particle. Okay, that is direction of velocity of particle. So there is some angle, that is theta, between velocity and magnetic field. So in that case there will be two components of velocity. This is perpendicular component. Perpendicular component means perpendicular to magnetic field, and another component is parallel to the मैग्नेटिक फील्ड. तो अब हमारे पास क्या हो जाएगा, जो हमने पहले डिस्कस किया है, अगर वेलोसिटी परपेंडिकुलर है मैग्नेटिक फील्ड के, इन दैट केस मोशन ऑफ चार्ज पार्टिकल इज सर्कुलर. तो हमारे पास ये जो परपेंडिकुलर वेलोसिटी है, इसकी वजह से जो चार्ज पार्टिकल का मोशन आएगा वो कैसा आएगा, दैट वुड बी सर्कुलर. और ये जो पैरेलल वेलोसिटी है, इसकी वजह से हमारे पास चार्ज पार्टिकल का मोशन कैसा आएगा. सो ये जो पैरेलल कंपोनेंट है, इसकी वजह से इस पे कोई फोर्स नहीं, मतलब पैरेलली अगर कोई चार्ज पार्टिकल चल रहा है, अगर वेलोसिटी जो है पैरेलल है मैग्नेटिक फील्ड के, सो एंगल वुड बी 0 डिग्री. इन दैट केस देयर विल बी नो मैग्नेटिक फोर्स. सो अगर मैग्नेटिक फोर्स नहीं लगेगा, दैट मीन्स पैरेलल कंपोनेंट ऑफ वेलोसिटी विल नॉट चेंज. सो जो फोर्स होगा मैग्नेटिक फोर्स, वो इस पैरेलल कंपोनेंट के लिए 0 होगा. देयर विल बी नो फोर्स ड्यू टू दिस पैरेलल कंपोनेंट. सो दैट कंपोनेंट ऑफ वेलोसिटी will not change its magnitude as well as direction. And for perpendicular component, direction will be changed due to which motion of particle is circular. So अब क्या होगा, circular motion as well as linear motion. तो दो मोशन के कॉम्बिनेशन से हमारे पास क्या बनेगा, हेलिकल मोशन. ओके प्लीज फोकस ऑन योर स्टडी. I can see you in on the cameras. I will start asking question individually. So जो हमारे पास कॉम्बिनेशन आएगा सर्कुलर मोशन एंड लीनियर मोशन का, दैट वुड बी हेलिकल लाइक दिस. ओके, सो सर्कुलर मोशन एज वेल एज लीनियर मोशन. सो जैसे आपने स्प्रिंग देखा होगा, ओके, इन द केस ऑफ स्प्रिंग, इन द केस ऑफ स्प्रिंग, तो उसमें भी कैसा होता है, हेलिकल होता है ना वो भी, सर्कुलर एज वेल एज लीनियर. ओके, या आपने स्क्रू देखा होगा, अगर आप स्क्रू को घुमाएंगे तो उसमें जो उसके हेलिकल्स होते हैं वो भी आगे की तरफ मूव करते हुए दिखते हैं ना, और साथ में क्या है, सर्कुलर मोशन. So that helical motion would be there if velocity is at some angle with the magnetic field. So consider a case when velocity of particle has both perpendicular and parallel components of along the B. So for parallel component of velocity, the motion along the magnetic field will not be affected because there will not be any magnetic force due to component of velocity which is parallel to magnetic field, because in that case theta is 0 degree. Okay, so motion along the magnetic field will not be affected. So parallel component of velocity, that is v parallel, remains unchanged. And parallel component of velocity will make the charge particle to move along the direction of magnetic field. So that parallel component will result in linear motion of that charge particle. And perpendicular component of the velocity produces the circular motion, as we have discussed. So due to combination of both linear and circular motion, charge particle will follow the helical motion. Now for helical motion, there is one term, that is pitch. Pitch of that helix. So we'll discuss what is pitch. So pitch is distance move along magnetic field in one rotation. ठीक है, pitch of spring, anything. So screw gauge you may have discussed in 11th class. Screw gauge, pitch क्या होती है कि जो सर्कुलर स्केल होता है, अगर उसको रोटेट करोगे आप तो एक रेवोल्यूशन में उस सर्कुलर स्केल में लीनियर डिस्टेंस कितना ट्रेवल किया है. सो हाउ मच लीनियर डिस्टेंस इज ट्रेवल्ड इन वन रोटेशन. अगर आप उसको चार्ज पार्टिकल की एक रोटेशन देखो, ठीक है, सपोज हेलिकल मोशन है हमारे पास, तो चार्ज पार्टिकल यहाँ से स्टार्ट किया और एक रोटेशन उसकी यहाँ खत्म हुई. दिस वन रोटेशन कंप्लीटेड हेयर. सो दैट इज द अमाउंट ऑफ लीनियर डिस्टेंस ट्रेवल्ड बाय द चार्ज पार्टिकल. ओके, यहाँ से चार्ज पार्टिकल स्टार्ट हुआ क्योंकि कंप्लीटली सर्कुलर मोशन नहीं है, हेलिकल मोशन इज देयर. सो there is some linear distance traveled and that linear distance is known as pitch of that helix. तो उस pitch का हमारे पास क्या फॉर्मूला हो जाएगा, तो pitch क्या हो जाएगी हमारे पास, ये लीनियर जो डिस्टेंस ट्रेवल्ड है वो किस वेलोसिटी की वजह से आ रहा है, पैरेलल कंपोनेंट ऑफ वेलोसिटी. जो लीनियर डिस्टेंस ट्रेवल कर रहा है चार्ज किसकी वजह से है, पैरेलल कंपोनेंट ऑफ वेलोसिटी. और एक रोटेशन में हम देखेंगे कितना होता है लीनियर डिस्टेंस. सो डिस्टेंस क्या होता है, स्पीड इनटू टाइम. ओके, और हम डिस्प्लेसमेंट अगर देखें, वेलोसिटी इनटू टाइम. So linear distance traveled is due to parallel component of velocity multiply by, and we are seeing and we are noticing the distance traveled in one rotation. So in one rotation, what is time? That is time period. Time period of that charge particle. Okay, so pitch can be given as V parallel into time period. And what is time period? We have discussed time period is 2 pi m by qb. So pitch is 2 pi m by qb multiplied by v parallel. That is the parallel component of velocity. So that is pitch of the helix in the case of helical motion. Now we will see some questions based on this topic. So this topic is also very important. Generally question came from that topic. Any doubt till that topic? Okay. So before that, there was one question from current electricity we were doing in our previous lectures. So there was some confusion in the options. Okay. So question was, in Wheatstone bridge network, four resistances PQRS are connected. Okay. So if bridge is initially balanced and the temperature of the resistor P is increased, then to restore the balance. So we have discussed, in that case, balanced Wheatstone bridges P by Q equal to R by S. That we have discussed. Because if we consider any standard problem, so in that case, if this is galvanometer, so this is P, this is Q, this is R, and this is S. In any standard problem, we consider the names of these resistors like that, P, Q, R, S. And we have the balance condition P by Q equal to R by S, or you can write P by R equal to Q by S by cross multiplying. Same thing. But in that question particularly, it was given. Okay. So it was missed by me also. So it was written P, Q, R, and S are connected in order to form a loop. So in order. So in particular question, they have written they are connected in order. That means P, Q, and we have to move in order. P, Q, R, S, like that. अदरवाइज जो भी हम स्टैंडर्ड प्रॉब्लम करते हैं जिसमें स्पेसिफिकली ये नहीं दिया गया, हम पी क्यू आर एस इस तरह से लिखते हैं. बट इस क्वेश्चन में उन्होंने बोला हुआ है कि इन ऑर्डर लेना है आपको इन अ लूप. सो पी क्यू आर एस. सो इन दैट केस द बैलेंस कंडीशन इज पी बाय एस इक्वल टू क्यू बाय आर, और वी कैन से पी आर इक्वल टू क्यू इनटू एस. सो इन दैट केस नाउ टेम्परेचर ऑफ पी इज इंक्रीज. सो अगर टेम्परेचर इंक्रीज हुआ है तो पी का रेजिस्टेंस इंक्रीज हुआ है. तो अगर बैलेंस कंडीशन हमें मेंटेन करनी है, हमें या तो आर रेजिस्टेंस को डिक्रीज करना पड़ेगा, या क्यू को बढ़ाना पड़ेगा, या एस को बढ़ाना पड़ेगा. तो इसमें से कौन सा ऑप्शन हमारा करेक्ट है? सो फर्स्ट ऑप्शन रेजिस्टेंस ऑफ क्यू मस्ट बी डिक्रीज, दैट इज नॉट ट्रू. बी ऑप्शन रेजिस्टेंस ऑफ एस मस्ट बी इंक्रीज, दैट इज ट्रू. रेजिस्टेंस ऑफ आर मस्ट बी इंक्रीज, दैट इज नॉट ट्रू. And resistance of R must be decreased is not true. So B option is correct in this question. Yes, PM Shri. I don't know how to pronounce it. Deorali or so very good. B option is correct. Okay, so there is this question. So easy question based on conceptual knowledge. So straight wire is held horizontally along the geographical north-south direction. Okay, so a current is switched on to flow from south to north. According to Oester's findings, a magnetic compass needle placed directly above the wire will have its north pole deflected toward the north, south, east, west. तो इसमें कौन सा रूल आपको अप्लाई करना है डायरेक्शन फाइंड करने के लिए? एक करंट कैरिंग वायर है, करंट की डायरेक्शन क्या है? साउथ टू नॉर्थ. तो कंपस निडल वायर के ऊपर है, इट्स अबव द वायर. सो इसका नॉर्थ जो होगा किस डायरेक्शन में डिफ्लेक्ट होगा? वो उस डायरेक्शन में डिफ्लेक्ट होगा जिस डायरेक्शन में मैग्नेटिक फील्ड होगी अबव द वायर. एंड व्हाट इज द डायरेक्शन ऑफ मैग्नेटिक फील्ड अबव द वायर? By which rule you can find? Okay, B option, C option. Okay. Anyone? Any other option? D option. Okay. Okay, C. So you have to point your thumb in the direction of current. So you have to point your thumb in the direction of current. So in which direction current is there? South to north. So you have to make like this. This is north, this is south, this is east, and this is west. Compass needle is above the wire. Current is from south to north. So you have to point your thumb in the direction of current, south to north, and curl your fingers. And above the wire, what is the direction of your fingertips or curling of fingers? So in which direction your fingertips pointing? Above the wire. Towards east or towards west? North south is wrong option. A and B is wrong. So out of C and D, which option will be there? Above the wire, what is the direction of magnetic field? C, yes, towards east. If you curl your fingers, your fingertips will point in the direction east, above the wire. And below the wire, they are pointing towards west. Above the wire, they are pointing towards east. So in question, it is asked above the wire. So which option is correct? C, east. Okay, so directions are very important in this chapter. Many students get confused in the directions. Okay, next question. This is very important type question. These type of question will appear. An alpha particle that is having charge plus 2e. E is the elementary charge that is having magnitude 1.6 into 10 raised power minus 19 coulomb. Okay, so alpha particle. What is alpha particle? That is helium-2 positive. That means helium nucleus. That is the alpha particle. So alpha particle, it is having charge plus 2e, and a proton that is having charge plus e. Enter a region of uniform magnetic field B, perpendicular to their direction of motion. So they are entering perpendicular to the direction of motion. So theta is 90 degree. That case we have discussed. So if charge particle is entering perpendicular to the magnetic field, it will follow circular path. And both particles enter in the region of uniform magnetic field with the same kinetic energy. What is the ratio of radii of their circular paths? That means R alpha by R proton. What is the ratio? So R is mv by qb. And I have told you another form. So they have given same kinetic energy. So you have to modify this formula in the form of kinetic energy. That is 2m kinetic energy by qb. Now magnetic field is same. Both are entering in the same region of magnetic field. So magnetic field is same. And also kinetic energy is same for both the particles. So R is proportional to root m by q only. Other things are same for both the charges. When you take ratio, same quantities will cancel out. So same quantities cancel out हो जाएंगी. Kinetic energy same है, magnetic field same है. जब आप ratio लोगे वो same quantities cancel out. Proportionality किसके साथ है? सिर्फ root of mass divided by charge. So R alpha will be proportional to, so I will write proportional to mass of alpha particle upon charge of alpha particle. And R proton is proportional to mass of proton and charge of proton. So you have to take the relation. So Q is 2e, Q is e. So that means charge on alpha particle is double. the charge on proton. That means charge on alpha particle is 2 times the charge on proton. And mass. What is the relation between mass of alpha particle and mass of proton? Mass of alpha particle is how much times the mass of proton? Mass of helium nucleus is how many times the mass of proton? Anyone? So there are 2 protons, 2 neutrons in the helium nucleus. So mass of alpha particle is 4 times the mass of proton. So mass of proton is 1U. Mass of helium nucleus or helium is, or we can say mass of alpha particle, that is 4U. Atomic mass unit. So you have the relation. Now you can take the ratio. Put M alpha and Q alpha in the terms of MP and QP and take ratio and tell me which option is correct. So R alpha is 4 MP upon 2 QP upon RP. So RP is root MP into QP. So QP and QP will get cancel out. Okay. And what we will get? Root 4, 2. So 2 and 2 will get cancel out and root MP will cancel out. So 1 by 1. So 1:1. Very good. Those who have written A. Next question. A particle of mass m and charge q is projected into uniform magnetic field B, and that B naught is the magnitude, k cap is the direction of magnetic field, that is along positive z axis, with an initial velocity. So velocity is also given v1 I cap plus v2 k cap. The pitch of the helical path traced by the particle is given by. So what is pitch? Pitch is 2 pi m v parallel upon qb. So what is v parallel here? Which component of velocity is parallel to the magnetic field? Very easy question. The component which is parallel to the magnetic field, that component you can replace with the v parallel, and that will be the option. So which option is correct? B option. Very good. Clear? Any doubt in this? Okay, no doubt. Now we have Biot-Savart law. ठीक है, हमारे पास कोई, हमने डिस्कस किया कि करंट कैरिंग कंडक्टर्स जो होते हैं उनके आसपास मैग्नेटिक फील्ड होती है. ओके, दे विल प्रोड्यूस मैग्नेटिक फील्ड अराउंड इट. मूविंग चार्जेस आर प्रोड्यूसिंग मैग्नेटिक फील्ड अराउंड इट. अब हमारे पास कोई कंडक्टर है, ठीक है, उससे कुछ दूर हमारे पास कोई पॉइंट है, उस पर कितनी मैग्नेटिक फील्ड होगी, ये कैसे फाइंड कर सकते हैं हम? मैग्नीट्यूड ऑफ मैग्नेटिक फील्ड एंड हाउ वी कैन फाइंड द डायरेक्शन ऑफ मैग्नेटिक फील्ड, दैट इज गिवन बाय Biot-Savart law, and it is very important. Applications are very important. Okay, so today I will give the expression for Biot-Savart law. Tomorrow we will discuss the applications and some questions based on this. So in this diagram, you can see, so there is one conductor XY. Okay, it is of any arbitrary shape. So shape is not fixed, that it is straight line or it is circular loop or any other shape. So it is some arbitrary shape and current is flowing from X to Y. और अगर हमारे पास P point है यहाँ पे, suppose there is P point here and we want to find the magnetic field at that P point due to this current carrying conductor. I current is flowing through that. Suppose हम क्या करेंगे, अब हमारे पास क्या है, ये किसी arbitrary shape का है, okay, and we don't know the length of this conductor also. So we consider very small element. तो जब हमें हमारे पास ऐसा कुछ arbitrary shape का आ जाता है तो हम क्या करते हैं, एक small element जो है कंसिडर करते हैं. तो हम यहाँ पे एक वेरी स्मॉल एलिमेंट जो है कंसिडर करेंगे एंड दैट करंट इज नोन एज करंट एलिमेंट, दैट इज रिटन एज आईडीएल. ओके, एंड व्हाट इज डीएल रिप्रेजेंटिंग? द मैग्नीट्यूड, द लेंथ ऑफ दैट एलिमेंट, वेरी स्मॉल लेंथ, एंड आईडीएल इज नोन एज करंट एलिमेंट. ओके, सो इस करंट एलिमेंट की डायरेक्शन क्या है? जो करंट की डायरेक्शन है, सेम डायरेक्शन एज करंट. ओके, सो हमारे पास क्या है यहाँ पे, P पॉइंट जो है, P पॉइंट के लिए जो पोजीशन वेक्टर है, ओके, मतलब इस DL जो आइडियल एलिमेंट है हमारे पास, उससे अगर हम देखें पोजीशन वेक्टर इस P पॉइंट का, दैट इज R. तो यहाँ पे हमारे पास कितनी मैग्नेटिक फील्ड हो जाएगी स्मॉल एलिमेंट की वजह से, दैट इज dB. एंड दिस इज द डायरेक्शन ऑफ दैट करंट एलिमेंट, दैट इज सेम एज द डायरेक्शन ऑफ करंट. सो स्मॉल एलिमेंट में करंट की डायरेक्शन ये है, जो ये डैश लाइन है, दैट इज द डायरेक्शन ऑफ करंट, दैट इज टेंजेंट टू दैट करंट एलिमेंट. सो डायरेक्शन ऑफ करंट एलिमेंट and position vector. So angle between direction of this current element and position vector is theta. So what is the magnetic field? We will find. Okay, so according to Biot-Savart law, that magnetic field on that point, that is directly proportional to the current flowing and that current element. First thing. Second thing, it is directly proportional to the length of that current element, that is DL vector, and it is inversely proportional to the square of the distance. So that distance is the magnitude of that position vector from that current element to that point P, where we want to find the magnetic field. And combining this all the proportionalities, you will get dB is proportional to IDL cross R upon R. That you will get. Okay, this is in the vector form. If you want to find the scalar form, so scalar form is IDLR, so cross product, so IDLR sine theta upon R cube. That is the scalar form. And after removing the proportionality, you will get the constant, that is mu naught by 4 pi. Okay, that is having expression 10 to the minus 7 Tesla meter per ampere. So we'll talk about it in the tomorrow's class. So your time for your next class is there. So thank you very much. We'll start from here.